Greetings everyone and welcome to Promaxis IT Training's complimentary webinar, Java 11 to 15, What Fun! It is my pleasure today to introduce you to our special guest presenter, Ian Darwin. If you enjoy today's webinar and would like to book any courses with Ian, please contact Louis at promaxistraining.com. There's also a question period at the end of today's webinar, so please hold your questions until that point. Ian, welcome. The floor is yours.
Thank you, sir. Welcome aboard. Welcome, everybody. Glad to have a bunch of people watching. So we're here to talk about what's new in Java, and it's going to be kind of organized by Java release number. So this guy, you've probably seen him before. It looks a little bit like the one from the Baby Yoda from the Mandalorian, but you can tell by the walking stick. It's actually the one who says, "When you are this old, you will look so good you will not." His other famous saying is, "Always in motion the future is," and that's certainly true with Java because we are now on a 6-month release cycle. So every 6 months, there's a whole new version of Java with new features, and it's really hard to keep up. So that's kind of why I put this talk together. So Java goes back to 95, the same age as Windows 95 and the design patterns book and various other things that happened way back then. But some of the important releases in recent times are 1.5, 1.7, 1.8, 11, and 14. We're going to talk about a couple of things from 1.5 and 1.7 just to be sure everybody's relatively up to speed on Java, mostly talking about 1.8 and 1.11 and later. Now, the presentation is really a catalog of changes by release. So most of the examples will have code examples. Most of the talk will have code examples, and I'll run them and show them to you and talk about them. It's not just slides. The code can all be downloaded. There is a GitHub repository there at the URL shown there, and I'll repeat that at the end in case you didn't get it copied down just now. Most of them are in the subfolder shown here, Java source main Java. Sorry about the complexity of the URL of the directory path, but that's the way Maven likes to find things. And there's multiple Maven projects within Java source. So anyway, enough on that. Just a background, viewer discussion is advised because there are so many changes to Java, depending on when you learn Java. If you learn Java like in college 5 years ago, then there's a heck of a lot of stuff that's new in Java that you probably haven't been taking advantage of. Whereas if you learn Java last year, then you're probably reasonably close to being up to date. But everyone's different, so we'll go through all this stuff. Starting with Java 5, and these ones I won't give code examples of because these are kind of things that we take for granted nowadays. But there is the for each loop that was introduced in Java 5. Incidentally, timeline, Java 5, 2005-ish, so 15 years ago. But I still run into people, and when I do full Java training programs, I still run into people that don't know all this stuff even on this slide. So I just want to reiterate this briefly. The for each loop, the enumeration types, the enum keyword, annotations, which allow you to attach metadata to code, the generic types, the types in angle brackets after another type, for example, list of string instead of just plain list, the concurrency utilities, thread pools, atomics, synchronizers, and a whole bunch more. Printf, the ability to specify format control over printing, passing an argument list. That printf was adapted from or borrowed from the C language, and it works the same way. Scanners and the scanner classes for reading particular input types, and variable argument lists on methods, var-args for short. So those are all things that were introduced in 2005 timeframe, and that most of us take for granted nowadays. But again, depending on when you started with Java, they may or may not be new to you. The next release I'll talk about was Java 7, which was mainly there for simplifying code for the average developer by removing tedious coding, which is a theme that we'll run into several times today because there's been a tendency over time to move in that direction. The first one in that instance is type inference for generics, or the so-called diamond operator. And that says when you're declaring an object of a generic type, you don't have to repeat the type list of string, list angle bracket string, x equals new list. And in the new list, you don't have to repeat the type. You just put an empty type parameter, which looks like a diamond. That's the diamond operator. String switch allows you to use string constants rather than integers for the constants in a switch. So you can switch on names and addresses and so on. Binary constants, where you can put bits, it should be called bit string constants, really put in a value as a bit pattern rather than as a integer or octal or hexadecimal number. Use of underscore as a numeric group separator. So you can put a time like 3 billion into, you can't put commas in because those have a special meaning already in Java, but you can put separators in to make the size of an int or long more readable. It's totally optional, and beware that they're not checked. So if you put underscore 00 underscore, people will get really thrown by it. The compiler won't care, but you have to be a bit careful with those because they're just basically ignored by the compiler. Try with resource and multicatch. These are ones that, this is one that people quite often don't have access to, don't know about. So I'm going to talk briefly about that. So the Java source package as a whole has, source main Java has about 80 or so packages in it. You don't have to look at all of them, but lang is stuff that is basically related to the Java language. Try with resource allows you to declare and initialize a closable type in the try statement. So instead of just saying try open curly brace and then assign the value and then at the end put a finally clause and remember to close it, by putting both the declaration and the initialization in the try statement, the compiler will actually remember at the end of the try block, it'll remember to do the close for you automatically. So it's typing, like I said at the beginning of the slide, less remove tedious typing, and it's also less error prone because people quite often forget to close things. There's no reminder. There didn't used to be a reminder ever that, and some compilers still don't have it, that you have forgotten to close something. So you just put the declaration and the initialization all has to be in one place inside the try statement in round brackets. You can have more than one with semicolons between them, like an input stream and an output stream, for example. I just wanted to keep the examples simple for the most part. You still need to catch whatever exceptions are required, like IO exception, but the key thing is you don't need the finally. And we also have in the same general area, we have something called multi-catch that allows us to catch multiple types, multiple exception types with a single catch block. So catch instantiation exception or illegal access exception or class not found exception, any of those, you put the type with a vertical bar, meaning or, and at the end of, or after the last one, you put the variable name that you want to use inside the catch. So that is the multi-catch mechanism. We covered try with resource and multi-catch. JVM invoke dynamic, that is a machine instruction in the JVM that is used by other languages, and it's designed to make it easier for other languages to cooperate in the JVM. I don't have slides on that because it's a machine level thing. And JVM performance, it's faster and there's better garbage collection. Garbage collection is one of the things that they work on in practically every release. There's a team that specializes in looking at garbage collection, and there's almost always improvements in that area that will make your programs run better. On my website, shown at the bottom, I have a list of more detailed changes from the beginning of time up through Java 7. And stuff Java 8 and later is in the Java cookbook. So Java 8 was a big release in terms of changes. There is default methods in interfaces. So interfaces can have methods in them that have code in them. They will be inherited or effectively implemented by every class that implements the interface. This is a cool mechanism because it allows you, if you're the maintainer of an interface, it allows you to add functionality to all the classes that implement your interface without having to go through and change all of them. So it's a very powerful mechanism. You have to use it sparingly because there's no way of reversing it once you've made something public, but it's a really good mechanism. So we've always said up to Java 8, we always used to say that interfaces are different than classes because they don't have actual code in them. Well, that's no longer true. So they broke. This is one of those shocking changes that I warned you about. Interfaces, yes, can have code in them. Also in Java 8, they introduced a JavaScript interpreter into the JDK, not into the language, accessible with the scripting API. And I'm not going to show that because it was fairly short-lived. The date and time API, however, is important. And they have come out with a total rewrite replacing date and calendar classes, which are now considered obsolete. They're going to be around till the end of time, I'm sure, but the new code is recommended to use the date and time, the new date and time stuff. We don't even call it that. They didn't put new in the package name like Java new date or anything stupid like that. They did that with java.nio back in 1.4 and it's no longer new, but it's still called Java NIO. And they actually added a bunch of stuff to it later on, as we'll see. Main classes, some of the main classes, local date, local time, and local date time, which are, of course, the year, month, day, and the hour, minute, seconds, either independently or together. The three local ones do not have any time zone information associated with them. So they're good for just simple calculations. There's also the equivalent zoned date, zone time, zone date time, and so on, which do have a time zone. And there's also period and duration, which are time intervals. All of those data classes are what's called immutable, which means they cannot be changed once they've been created. And that's good from a thread safety point of view. It's not quite as good as performance because if you're changing something a lot, you wind up creating a lot of new objects. But Java over the years has gotten really good at, really efficient at creating small classes. So the overhead of doing that is much reduced, very small. And it's actually better from a reliability point of view. There's a now function in most of them. So you can say local date time dot now, which will print out the current date and time. It's that simple. I'll give you a couple of code examples from that. In my Eclipse, we have many more examples in this package than I'm able to show you here, just showing some of the highlights. Date add. You can start with today's date. You want to see what is the date going to be in 700 days from now. So you can say local date dot now. You can construct a period object with the number of days that you want, and then say now dot plus. You can also, there's a shorter way of doing this. You can write now dot plus days 700, which will have the same effect. In fact, I should probably just do that. Make it more efficient. Again, avoid tedious typing whenever possible. That's our new motto. So 700 days from now is going to be, I don't know what that's going to be. Let's run it and see. 2022. Oh, Yeah. Nope. Forgot the semicolon. (2021, 2022, December 23rd. So there you go. And the other one is a little more involved example, date calculations. Suppose we want to find out when payday is. If you have weekly or monthly employees, you can start with local date time now, and then you can say with temporal adjusters. That's a class in the same package that has a whole bunch of adjusters in it. For example, next, find the next occurrence of Friday. That happens to be today. Weekly employees pay day Friday, and the month and the day of the month. And we can also say monthly, they are temporal now, again, starting from today, finding the next occurrence of the last day in the month, the last Friday in the month. So that will print out the day when those two groups get paid. And because it thinks this Friday has already happened, it gives us next Friday. But that's okay. And monthly employees also get paid on the 29th. And that should have been a local date, not a local date and time. But anyway, that's the idea. So there's a ton of stuff in the date and time package. You are encouraged to learn to use at least the basics of it, and you can do all sorts of fancy calculations. There's another example in here that figures out the flight arrival time. If somebody's going on a transoceanic flight and when the pandemic's over, and you want to know what time they'll get there and what time the person has to leave for the airport to get to them, to meet them on time, that sort of thing. So you can do that calculation all using modifiers like this. It's a very powerful mechanism. The other feature of Java 8 is the Lambda expressions. Lambda expressions, interface features, and streams, which together give us steps towards functional programming. Functional programming includes the notion, functional programming has been around for a long time, and it's a kind of an idea like object-oriented programming. And it features, there's no single exact definition of it. Different people have slightly different ideas about what it really means, but some of the key features typically include the notion of code as data, which is that you can take a piece of code, like a method, and pass it around or return it from a method, pass it into a method, invoke it dynamically, all sorts of things like that. This idea is not new. This comes from the Lisp language, which was developed not that recently, like in the 50s, 1950s. So this is not a new idea. Functions which don't have side effects, which is important. That leads to code that you can verify the correctness of the code more easily. The implication of that is immutable data objects. That's why the local date time objects are all immutable. It not only makes it thread safe, but it also means you can be sure the code's going to work correctly. That's the key thing. Lazy evaluation, that's a way of life, so that things don't get evaluated unless they're actually going to be needed. There's a number of functional programming languages from the last decade or so, or several decades in some cases. Erlang, Haskell, which are their own languages, and OCaml, which is another one. Scala and Clojure are both JVM languages that are pure functional languages. And Java, of course, with all these new features, it can be thought of as a partly functional programming language, but it will never, ever be a purely functional language because there's just too much code already written that depends on object mutation, object changeability, mutability. So I don't think Java will ever be not in our lifetimes anyway, become a pure functional programming language. Nonetheless, it's useful to have these features in the language. One of the key aspects of this is what are called lambda expressions. And again, the lambda calculus goes back to the early years of the last century. Lambdas in Java, also called closures in some other languages you may have met, simplify coding so that if you have a class or even a method that's only used once, you don't have to make up a bunch of stuff around it. There's the DRY principle, which I hope most of you know the meaning of. DRY standing for don't repeat yourself. And the idea behind this in the Lambda area is to make the compiler do more of the work for you, in particular, to do some very extensive, what's called type inferencing, where whenever the compiler can figure out what type something is, it will do that for you and save you from having to type it out. We also have the notion of what are called functional interfaces, which are interfaces which have only a single, in the old days we would have said a single method, but now we have to say a single abstract method because of default methods. But nonetheless, there are quite a few of these. Runnable, which you're probably familiar with from anything to do with threading, or action listener, which you may have used in Swing applications, or anything similar, are functional interfaces, and they can be used with Lambda expressions. The syntax of a Lambda expression is the little bit shown right in the middle of the slides. Parentheses, arguments, the arrow, and some piece of code. Now, the argument list, there may be, of course, like any method call, there can be no arguments, one arguments, or more than one arguments, and that depends on the interface. In the case of runnable, for example, in the case of runnable, there are no arguments. In the case of action listener, there's one. If there is exactly one, you can omit the parentheses around it, again, to avoid extraneous typing. If there's zero, you have to put an empty parentheses. And of course, if there's more than one, you have to list them out. Because what you're doing in a Lambda is basically providing a method declaration. Also, if there's only one statement, you can omit the curly braces around the block and make sure you end it then with a semicolon. Now, Lambda expressions, a good demo of using them is the iterable interface, which is implemented by all of the collections classes. They added, at the same time they did all this other work, they added a new default method just for you to make your life easier called for each that allows you to iterate through a list or a set or a collection and do something with every element without having to write without having to write an explicit for loop even. Just list.forEach with a lambda. They also introduced one more bit of syntax just to keep us on our toes here on Java 8 called method expressions, which are two semicolons in a row. Let's take a look at some of those. The lambdas is in functional. So here's a simple example. We have this is from a Swing application. We have a J button, a J text area, and we had in the old version, we have this action listener here, class that implements action listener. And in the action perform method, we're called with an action event, which we typically don't even use. And then we set the button to be disabled, to do something with the action event, put it as the text of the text area, and then re-enable the button. So that's meant to, it's not very meaningful, but it's meant to be typical of the kinds of things you might wind up doing in a Swing application. So what I've done in the code here at line 16 is I've replaced these 2, 4, 6, 7 or 8 lines with one statement, which is instead of saying new my action listener, I've replaced it. So I've still got the parameter list to the method call, to the method action performed. And I've still got the body of code from here, from here down to here. But in fact, I don't even need that because the compiler knows what kind of thing is allowed as the argument there. So I've taken the E from here. That's my reduced parameter list because the compiler is going to figure out the type. And I've told it it's going to be an action listener. And I've got the code here, and everything else has gone away. So the public class my action listener implements action. All that typing is avoided. And the public void action performed, action event, all that typing is avoided. And we just take the various pieces that we really need, like the parameter and the body of the code, stick it here with the arrow or implies notation, and we're done. So it doesn't get much more concise than that. Well, actually it does, because if I didn't need to print this, I could declare the action listener right in place here. So that really all I need to say is button.addActionListener, the parameter list from the method E, that's this E here, and this body of code, and I'm done. So again, it doesn't get much simpler than that. We also have one more example of this in the structure. That's laying structure. Where have you gone? There you are. In the method references. So I have a list of various strings, and now the new pattern for iterating through a list or set is as follows. List.forEach. Remember I said that's a new default method in the iterable that is implemented by most of the collections. For each, and then I pass a reference to the method system out print line, and there's an interface defined for that, which is consumer, which takes one argument, which is what printline takes, or multiple arguments, which printline takes. And so we just have to put the name of the method here, and assuming it's a method that can handle one argument passed into it, this will just work. That really is all we have to say. It's list.forEach and then some function that we want to operate on that. Just to show that it does in fact work. Run it and we get the output of the list. Cool. Another feature of Java 8 is the streams. A stream is a logical data flow. If you're familiar with Unix pipes, it's sort of like that, except it's within the application. And because it's not going out to the operating system and buffering, it's way more efficient. There's an interface called stream in Java util stream, and you can create streams from almost anywhere. And they can be coming from an array or from lists or sets or from IO files or whatever. And streams can do operations like filtering and sorting, counting, and so on. And they can do it either serially or in parallel. And the parallel streams will nicely handle threading for you and locking and so on for you. And the only requirement is the stream has to end with the terminal operation like count, average, or some sort of collector. Here is a simple demo of a stream. So I have a data class here called hero. This is superheroes like Superman and so on. Each one has a name and an age, and some of them are real and some are made up, I guess. The key thing is we take that array, this is a static array, and convert it to a stream using the arrays class. That's a helper class in the collections API. Dot stream, that says manufacture a stream for me. And that stream is coming from this list. And we then filter it to only take people whose age is greater than 18, greater than or equal to 18. That gives us a stream containing a subset of the hero's objects. And then we just want to take just the age part of that. So we do map to int. And again, using a lambda, these are both lambdas. B is replaced by b.age. So that gives us a stream containing only integers now. And then we just count them using sum. And that returns a long number, a long integer. And we print it out. We do another one, arrays.stream heroes, the same thing. Streams cannot be reused once they've been completed, like the sum operation. That stream is gone away. So we don't save streams. They're lightweight objects relatively. We just recreate them whenever needed. So we do sorted, and here we're comparing a sort, giving a comparator. This is a lambda expression for the comparator interface. And this is how we typically write comparators these days. Hero1 and hero2, hero1.name compared to hero2.name gives us a standard sort comparison, just like collections.sort or arrays.sort. We then map that again, like we did here, this time mapping an object to a string. And collectors are terminal operators that will simply collect all of the objects into a single object, in this case, to a list. And that gives us back a list of, it says list of objects, it should be list of string. And then we just print that out. So I'm going to print them both out by running this thing. And lo and behold, the adult superheroes have 243 years of experience, and the heroes sorted alphabetically, A, then F, then G, then J. You get the idea. So it sorted them correctly, and that's all. So that is a couple of examples of streams. There's way more to streams than that. That would be like a whole 1 or 2 hour lecture just on streams to get all the nuances. But I just wanted everybody to have at least a vague idea what they're about. Okay, that's Java 8. On to Java 9. Java 9 is the biggest thing in Java 9 was the module system, also called JPMS, Java package module system, or Java whatever. This is kind of the biggest single change in Java history because it provides better control of interlibrary access, which you might not think is important, but it really is. It was first invented for modularizing the JDK itself, because over the years, as we've seen, Java has grown bigger and bigger and become harder for the JDK people to maintain. So they wanted to break it into smaller pieces and for maintenance purposes. And that's where JPMS comes from. But they made it available for people to use in their own applications. There is a configuration file called a source file, I should say, called the module info file. And that has, interestingly, it has some what I call pseudo keywords. They are words that are keywords only in a module info, but not in a regular Java program. And thus, they're pseudo keywords. Here is an example of now, before I go into the example, just want to say the module system has caused, when it first came out, people didn't really understand it all that well, and it can cause a lot of confusion and misunderstanding. So before you switch over to modularizing your code, if you haven't already done so, um, make sure you understand well what's going on, because there are some nuances and some complexities to it. Just to give you a bit of the flavor here. I'm going to do this. See if I can. I'm used to using a control, a keyboard shortcut for opening files, and WebEx is blocking it, so I have to go looking for the resource. There it is, open resource, and I want to look for module info. So the one I'm going to show you, this is the one file that's not in the standard download. It's in a separate download in the same Git area called Darwin's API. So we'll pick that file apart. So it has the word module and the name of it at the top. It has things that it requires, java.desktop, and the transitive means everything that it in turn requires. Java.net HTTP, java.persistence, that's the JPA API. So there's a whole bunch of things that are required, all the individual packages that are exported. This one in particular says we're exporting an interface and we're making that one implementation of it available as well, so that code using this can simply create a pessimistic lock manager and we'll get that implementation of it with a tiny bit of code in the application. So that's basically what's in a module info, a list of all the other modules that you need and all the packages and other things like class implementations and so on that your package provides, that your module rather provides. So it's typical to have a module for each library and for each application. If you're not using the module system, but you're using a version of Java 9 or later, then what will happen is it will just put everything by default onto the module, all your jar files and so on, onto the module path using the same names that the file names have by default. So anyway, the other main part is JShell, which is a REPL, a read, evaluate, print loop program. In other words, a command interpreter. And we can demonstrate that by make that a little bigger so you can see it. And I just type JShell. And now I can just type Java commands at it. So and expressions get evaluated. It's basically an interactive Java interpreter at that point. Commands get interpreted. You don't need semicolons. You don't need imports for things that are in the standard Java desktop type stuff. And you can type almost any type of command at it and it'll work. Almost any Java code at it will work. You can even declare classes. And it just says there's a class, and now I can say new X. And it creates an instance of it. It uses $1, $2, $3, and so on for things that you didn't give a variable name to. So that's a brief look at REPL. Java finally has an interactive mode, which is really a big win for teaching Java and also for exploring any new API that you need. You can import it into the REPL and explore it interactively much more quickly than editing code and running it. So very powerful, very important feature. Interfaces can now have private methods as of Java 9. That's in support of default methods. So those would only be callable from from the default methods. List and set get an of method that allows you to create lists simply by putting items in the parameter list. I actually showed that in my previous example, so I don't need to repeat that. The other thing with Java 9 is that this is where they began the 6-month release cycle, which was kind of going from one extreme to another. Before that, they had done Java releases kind of randomly, sporadically, with sometimes a fairly short time period and sometimes a much longer time period between the releases. So now they said, boom, 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 every 6 months, we're going to crank out a whole new release. And that's why we have to go from 9 through to 15. They also announced that Java 8, which was already out, and Java 11, which wasn't out at the time, would be the LTS long-term support versions of Java. So for people that want stability and don't want to be bothered with LTS long-term support, is Java 8 or Java 11 if you don't want to be bothered. 8 if you don't want to be bothered with the module system and don't need any of the other features, and Java 11 for most people if you want long-term support and not have to. If typically, if you're in a business environment with a large development team, you do not want to always go to the very latest version of Java because it's every 6 months and it's a bit disruptive if you're a large shop. So the long-term stability, long-term support versions are kind of meant to be intermediate. I think 14 is the next one. I'll have to double check that. 14 or 15, somewhere in there. Java 10 comes along next, 6 months later, introduces the var type for local variables so that you don't have to stop and remember whether you want to type something as an int or a float or a double. You just type the name of it, a var and the name of it. For example, not finding it for some reason. Bear with me. There it is. So var x equals 12, that's going to be an int. Var y is math.py, which is a double, so that's going to be a double. And var z or z is 0, so that's going to be a string. And I print those out using printf, an example of printf, by the way. %d for decimal integer, %f for floating point, and %s for string, and a new line. And if I run that, there it is. So this comes out as 12, that's an int. This comes out as a floating point value, and that comes out as a string. So I didn't have to type any of those types. We also have graalvm, which is, I don't need to show you because it's the same Java. It's another JVM. It is a separate download. It's designed for support of multiple languages, not just Java. So Ruby and Python and Scala and Clojure, all the other JVM languages have better support. It's faster, and it even has support for native compile. So it will pre-compile, instead of relying on hotspot, the JVM, to translate important parts of your code from Java bytecode into machine code. The native compile will pre-compile the whole thing into native code. So the result is you get an executable in the native format like .exe for Windows or ELF for Unix or whatever it is for Mac. You can only build those on those platforms, so you need to have multiple machines available if you want to make a native version of things, but it's way faster. The CA certs, the certificate file was updated. It was long overdue, and that makes it more likely that if you use HTTPS, that it will be trusted. Java H, which was only used for native code, was removed because its functionality got moved into the Java C. List and set get a new method, copy of, which takes another collection as an argument. And this makes a true unmodifiable copy. There was a previous attempt at that called unmodifiable in unmodifiable list, unmodifiable set in the collections class that only made the copy of the main object so that if you change something in the list, it would show up in the copy. So the copy wasn't really unmodifiable. You couldn't modify it through the copy, but you could still modify it through the original. So this new method copy makes a complete copy so that changes to the original no longer have effect, and you still can't make any changes to it. The way they do that, of course, is that all the add and remove and so on methods will throw an exception if you try to call them. As with every release, I didn't say this before, but with every release, there's a whole long tail of little bits and pieces that I'm not even mentioning. Here, some older stuff got deprecated and some really old stuff got removed, but I'm not going to bother listing all that because you can find it online if you really need it, and the compiler will tell you if you use any of that stuff. So we don't have time to do everything. Java 11 was the first release that was pre-announced to be long-term support. And one of the key things is the fact that you can run single file programs from outside of your IDE. So you can just say, get out of JShell for a minute and pick a Java file. If you can type it correctly, it'll run it for you. And sure enough, they're getting into what that program does. Just run Java with the name of the .java file. Now, there's a limitation, of course. There can only be one class. And if you have multiple ones, then you have to compile them and put them on your class path like you always did. But a single program, just a single program for testing, again, for developing, for playing with small bits and pieces of code, this is, again, is a win. It's probably faster than you can just type it in with your text editor and run it with the Java command faster than you could with an IDE. Maybe, depends, but it's a nice feature. You can also take something useful and package it now as a batch file or shell script. And as you make changes to it, they will take effect immediately. So that's a really nice feature. There's something called nests and nestmates, which I don't cover today because of time and also because it's mainly useful for people writing libraries rather than people writing applications. So I'll have to leave that one for you to look up. Just look up Java nestmates and you'll find the information on it if you need it. Java 12. Java 12 introduced a new notion of what are called preview features. And the idea here is that sometimes when they added, in the past, when they had added new features into the language, they would get a certain amount of pushback from developers. So because they didn't like the way it was done or it didn't work for them or whatever. So preview features now allows them to put a feature out into the JDK. You have to enable it. So by default, you won't be bothered by these, but if you want to explore them or if you need to start using a feature immediately, in the command line, you put -- enable preview, and that enables all the features of the current release. And in Eclipse, for example, as one IDE, under Preferences Java Compiler, there's a checkbox for Enable Preview. And so that is how you enable previews. If you don't enable them, they won't bother you. Your code won't accept them, your code won't use them, and they won't have any effect. But if you do want to play with them before they get into circulation so that you can give feedback and decide if you like them or not, then by all means play with them. So here's some examples. Switch statements can now return a value, which is pretty strange, but it's very useful. I'll show that one. Yeah, hit the wrong button. Where did you go there? Under language, switch yields value. Language, here it is, switch yields value. So we have a variable x, which has a value 12. And just to show a simple example, we have a switch on x, and we assign the return from the switch to be a string variable. And so we have a number of cases, as we always do in a switch statement. If the case is 11, we do yield a string value 11. If the case is 12, which we happen to know it is in this particular case, yield the string you win. And if it's any value that isn't one of the listed cases, there is a default. When you are using this return from switch, you have to have a default, unless it's an enum and you've listed all the possibilities. And that gives us back a string, which we just print. So again, if I run that, I hope it's going to print you win. If it doesn't, I'm in big trouble. Yeah, you win. I win. That's good. There is also a new number format, compact number format. This is like the -h argument in a lot of Unix commands that now print really large numbers like disk blocks and so on as and disk usage and so on as these scalable numbers. H for human readable. This is in numbers compact. Compact, where did you go? Why do I not see it there? Go the other way. Compact format demo, there it is. So we have some numbers, 0, 1, 1 1/4, 1 2 3 4, 1 2 3 4 5, and so on and so on. And notice they're not even all the same type. Some of them are ints, some of them are floats, and some of them are longs. Doesn't matter. They can all be stored in an array of number. Number is the parent class of big I integer, big L long, and so on. We also have some strings that we're going to convert from strings to number form. And then, so we have two loops, one for each direction. There's no constructor for the compact number format. You simply say number format, get compact number instance, and use it to format. So we tell it here when we are, I don't know why this is done inside the loop. That could be done outside the loop. Some configuration stuff, but basically we do compact number format each of these numbers in turn. That's something my Eclipse editor has gotten very confused because it thinks this doesn't have a main program in it when it clearly does. So I'm not going to run it. I'll go on to the next part. The parsing, converting from string to number, is the same thing. Compact number format.parse. And it's too bad we can't show this. I'm thinking if I go into plain Java, I can run it. Make sure it's in the right place because I had trouble finding it before. Hmm. Well, trust me, it does work. We also have something called the T collector for streams. And again, if you remember streams from a few slides ago, they are the ability to process a chunk of data, a large, possibly large chunk of data sequentially through or in parallel through a bunch of filters and accumulate them at the end. So under functional, so I have a stream. And again, like list.of and set.of, there's a stream.of that lets you construct a stream on the fly from a static collection of objects that you know at compile time. And here we have Mac OS, various operating system names, obviously. We run that stream through the collect format. And the collect, remember, collect is a terminal operator, but we have to specify how we're collecting it. And this time we're going to run the entire stream through two different filters, which can overlap. The first one says filter, take the name, convert it to lowercase, and see if it ends with an X. Add that to the list. So that's going to should hit Mac OS X, Linux, and OpenBSD Unix. And the second collector is going to say if the name contains a W. So that should fix Windows and Windows XP and Windows 10. And the teeing function takes two collectors, and the collect takes two as well. So that's why there's a extra close parentheses here, and merging the results. That has to, the merge has always at the end of any stream has to return one single value. So this collects the list one and list two into a list of lists, which is handy because it means we can print that list out. So hopefully this Eclipse will be able to find this and run it. And sure enough, we get a list containing two lists. The first one with all the ones that end in X, and the second one with all the ones with W's in them. Okay, so that's an example of the T collector. Just a further example of the really powerful and complicated stuff you can do with streams. I, again, encourage you to learn more about the Streams API. There's coverage of it in the Java cookbook written by some guy named Ian Darwin, and there's plenty of other coverage online as well. Again, garbage collector improvements, no surprise there. Java 13, improved garbage collection again. They're always, like I said, they're always improving it. Something called APP-CDS, which is application class data sharing, which allows you to build an archive of the sort of pre-digested class files that your application is using, and that can lead to faster application startup. You have to do that explicitly, but it's a speed up. Text blocks, which is a preview feature that allows you to write long strings much more easily. That should be in the strings package. Which is too big. And again, I'm not seeing that text block demo. Says it's there. So we have this string called message that, notice for text blocks, you use 3 quotes in a row, which is the same as many other languages, including Python, use for multi-line strings. And then this string can be as long as my design, and quotes don't need nor pluses on each line. And that should be like that to rhyme better. I can just pass that into print line, and it will come out on 4 lines. So notice that when you look at it, it looks like there's going to be an extra new line here, but there isn't. You don't have to worry about it. It's sort of discarded. And ditto at the end. Another one at the end actually came out. So I could fix that by removing this and running it again. So now there's no extra line at the end, and there's no extra line at the beginning, certainly. So that is a look at text blocks. They're a preview feature here, but they're in Java 15, they're no longer preview. Oh, wrong window. Try this one. There's minor improvements to the switch returns a value. There's internal rewrites of the socket and server socket classes. These don't make any change on the API, but they make it more reliable and run a little faster as well. Keep up with changes in internet technology. Java 14, which is one of the recent ones, has something called record in it, which is really nice. It allows you to make data structuring classes without having to write constructors and getters and setters. Every Java application has these, and they're really a pain. So we got rid of them. You can write the whole thing with a couple of lines. And I have to show you that because it's so cool. APP-CDS is application class data storage. Navigate, open resource, and we're looking for record. So here, instead of writing public class person and then writing name and email as fields and writing a constructor with 2 arguments and saying this.x equals x, this.y equals y, and then having a set and get method for each, right? That's like this much code. Replace it all with 1 line. We're done. We can still say new person with a name and an email, and there's even a toString method provided. It's not as elegant as you might like, but it is functional. You can override methods like toString. Notice it also provides equals, hash code, and various other methods. And so this is very powerful. Big win in terms of having the amount of code you have to maintain for almost any application that has data objects in it. You can have other methods in them too. This one is so trivial I don't need any, but if I did, I could add methods inside the block. The second thing up here in Java 14, which is also in preview, is JPackage. Now, JPackage is a really amazing tool. It's designed to build native installers so that your Java application can be a first-class citizen on all the major platforms without having to go looking for third-party tools that do that for you. So I have an application that I wrote, which is a presentation tool that is for presenting from PDF when you don't have PowerPoint or OpenOffice Presents to show from the PDF directly. I won't bore you with the details of it, but I will show you one part. Um, so this is a script that I use that runs a tool called Maven, which is a standard Java build tool, to package the program into a single jar file. And then I run jpackage on that, which is the new tool that was added in Java 14, giving it various arguments like the name of the application, the release version, the license file, and all this other stuff. And the type here, I have to give the type. And so if we're on Windows, I set the type to MSI for Microsoft Installer. If we're on Darwin, which is the operating system name for macOS, I set it to DMG. If we're on Linux, I set it to RPM. And similarly set the icon format and maybe some specific OS-specific commands as well. And those get run here. And then that's all. So now, I will show you on another screen the actual application that was produced, and under releases, under the current release, there is the DMG for macOS, the MSI for Windows, and the RPM for Linux that were all produced using that script on 3 different machines, obviously. The thing as before, you can only build macOS native applications on macOS and Windows.exes on Windows and RPMs on Linux. So you do need to have all those machines available, but it's a really standardized mechanism for building the native installer for all of the 3 main standard platforms that are out there. Also in Java 14, text blocks, which are in their second preview, and a few other little things. Finally, we get to Java 15, which has, as you can see, has a long list. Something called sealed classes, which allows you to have control over subclassing. You can say that only certain classes are allowed to subclass your class. Flexible matching, for instance, of a preview. Records, I think, unfortunately, still in preview. Text blocks, which are out of preview, are standard in the language now. Something called hidden classes, which are mainly aimed at library builders, again, so I won't get into them. Nashorn, which was added only a few releases back, you remember, is gone now. They removed it. They rebuilt in the previous release, they rebuilt the TCP socket, and here they rebuilt the datagram socket. More garbage collections, a whole new garbage collector, which you can specify on the command line when running Java to have low pause time. Pause time is when your Java application is running along and suddenly the garbage collector needs to stop your application from updating the objects in memory so they can do some changes to them to collect the garbage, the unused, no longer used objects. So Shenandoah offers very short pause, very minimal pause times, making your application more responsive. Something called foreign memory access, and that is the ability to access if you're mixing Java code with some other language that uses its own memory allocator, you can access that memory from within Java. And finally, they deprecate one feature of RMI. RMI is the remote methods invocation for network access to Java code. And the activation part, which says don't load some feature until you actually need it, is being deprecated because hardly anybody uses it. It's left over from the days of overly ambitious plans for desktop applications that never really materialized. So that's Java 15, and pretty well all we're going to say for all the releases before it. Reminder, the code sample is here. GitHub.com, Ian Darwin, that's me. Java source, that's Java source. There's about 1,500 Java files, about 75,000 lines of code. You can do whatever you like with it. If you get rich off it, you can send me some money, but otherwise just have fun with it. And one more thing, Java 16 is coming in about another 2 months. So I'll need to update this and present it over again in a few months. So thank you all for being here. And now I'm going to, there's a URL there at the bottom, darwinsys.com/Java. You can find a lot of my resources there, and you can also sign up for a very low volume, I promise, mailing list where I talk about changes to Java and my books when they get reprinted or republished, new editions. So please sign up for that. And I think that's everything. So let me get out of here and see if we have any questions outstanding in the chat.
Thank you very much, Ian. It's been a pleasure having you for the last couple weeks now.
Thank you. Thanks. Yeah, it's been fun. Forced me to confront a few things that I had forgotten about as well. So that's always good. Thank you.
All right. Thank you very much. We're gonna
Last call for questions. Going
yeah.
once, going twice. Sold. Okay, Josh, over to you. Thank you.
Okay, thank you very much, everybody. If you have any questions, feel free to forward them to Louis at promaxistraining.com and or check out our website, promaxistraining.com. Otherwise, have a good day. We're going to close the meeting now. Thank you very much.
Have a good weekend, everybody. Thank you.